All right, here's this system of equations, 4x plus 2y equals 5, and 2x plus y equals negative 1. Okay, so let's try this one again. They're both in the same format, which is great. Okay, it does save us, maybe not a lot of time, but some time. Okay, so we're going to use the addition method. Hey, no problem. Okay, now the first thing I do on this one, again, we want the coefficients of one of the two values to be opposites. And usually, just like we saw with that previous problem there, is the coefficient of y is a 1, and that's a very easy value to work with. Even if the other coefficient were a fraction by chance, it'd be a very easy number to work with. So I would probably look at this one and say, hey, let's eliminate the y's. But I feel like we've done that, so I'm going to choose to eliminate the x's, not necessarily because you have to, but because we've already seen some elimination of y's, okay? So I'm choosing to eliminate the x's. So on this one, I chose to eliminate the x's. Now I see that the 4 is a multiple of 2. Now some people say in order to get these, force these to be opposites, they kind of choose to, let's say this equation I'm going to multiply by this coefficient of 2. And then this equation I would multiply by this coefficient of 4. And that would in fact force the coefficients to be the same. You just have to make one of them negative to make them opposites, okay? Now I see that the 4 is a multiple of 2, so I'm gonna work with that. Okay, so I'm gonna take the second equation, and I want that 2x to change into negative 4x's. Okay, so I'm gonna multiply this equation right here by negative 2. Why negative 2? Because when I multiply negative 2 by 2x's, it will give me the opposite of 4x's. All right. So what does this do for us? All right, so we're going to distribute this negative 2 into all three values here. So again, that's principle of equality stuff. Negative 2 times 2x's there would give us negative 4x's. And then negative 2 times 1y would be negative 2y's. And this would equal negative 2 times negative 1. And this is where we see a lot of mistakes. It's not a huge mistake, but it's common enough. Negative 2 times negative 1. A lot of students just put negative 2 right there. Maybe they miss one of the negatives or something like that, or just a brain fart in general, but that should be a positive 2 because it's a negative times a negative right there. Now, we didn't do anything to that top equation. So it still is 4x plus 2y equals 5. Now, on this one, we chose to eliminate the x's, but yeah, as we talked about there, I did eliminate the x's, and that's great. It's just right here I got 2y minus 2y. That'd give me this many y's, 0 of them, which I do want to account for. And I guess I should have shown we are adding these together, right? So 5 plus 2 there is 7. Now, going back to what we saw in Module 1, which was quite a while ago, but what can I multiply by 0 to get 7? There's nothing. This is never true. Yeah, I guess I should be careful not saying nothing, because then that could be interpreted as 0, you know, but it's just never true, all right? This is never going to be true, at least not with any real numbers. So this one would say no solutions, or as we've seen on the homework, it comes out as a DNE. And I actually kind of like these problems because look how much work I had to do compared to the other problems that we did. It's not even half the work. We got to this point and we're done. Now, please, this is another common error we see on a problem like this one that has no solutions, or even if it were infinite solutions, which, yeah, we'll see. But a lot of students say 2y minus 2y is y. Now remember, you need to account for that coefficient, that it would be 0 in that case, and then you just need to stop and ask yourself some questions. This should look at least slightly familiar based on what we saw in Module 1.